Alright, Assalamualaikum. So today we're going to continue to do the analysis lah for this stool that you have created. So this is a simple stool which has a thickness of about, let me check, shell here. Thickness is about 3 mm. So we would like to know whether 3 mm is good enough lah for the thickness of this stool. So in order to do analysis, you have to go to SolidWorks add-ins and click one time this one, simulation, and wait for about few minutes and it will load up lah, the simulation module. So this one has been loaded up. So these are all the modules which is available lah for SolidWorks. So let's go to simulation. So the first one is we go to the study advisor here and then click the arrow bottom and click new study and click on static, click OK. So under static you will see a few things lah. Number one here, static 2, this is the stool, and then you've got a few things here. Number one is fixture lah. So you need to first of all set the material lah. So right click here, apply and edit material, and you have to search for the material library. So it's under SolidWorks materials. Minimize this one, go to plastics, and then you look for polypropylene, which is this one lah, polypropylene copolymer. So it has an elastic modulus of this much. So you can even change the units lah. Units here you can change to megapascal. So elastic modulus is very low lah, 896 megapascal only. Mass density is 890, tensile strength is about 27.6 megapascal or Newton per millimeter squared lah. So you click apply. So once you've applied the material, you will be able to determine the weight of the part lah. You can go to evaluate and click on mass properties. So it will give you roughly about this much lah. Why is the density here 0/0? Mass here is about 1 kilogram. So this is attributed to the thickness lah. Currently it's about 1 kilo. So if you're not satisfied with this, you can go to your shell bag, go to features. I think I have to X this one first lah. Edit shell, change this one to 2 mm. 2 mm, click OK. So everything will be changed thickness lah. So if you go back to evaluate and click mass properties, now it's already been reduced lah, about 700 grams. Okay, let's say we are sticking with 2 millimeter lah. So let's go back, go to simulation. There is this thing called static here. There's a tab here called static. So stick to that tab lah. This one I'm going to delete. Just use the new one. Okay, so polypropylene copolymer. Another thing that you can put in your design, you can put something called sensor. So go to, this is under your static 2, right? You can go to model, go to sensor, add sensor. This is under mass properties, click mass and click OK lah. So under sensors, if you expand here, it will give you the weight. So you don't have to all the time evaluate lah. So the moment you change things, you can just update the sensor. So this sensor can add a few more things lah, other than mass properties. You can even put simulation data, stress, von Mises in megapascal, model maximum. So it is a stress value, and you can even put, can I put one more? Add sensor, simulation data. I want to find displacement in the y direction lah, or resultant displacement in millimeter, and then I'm going to click OK. So these are sensors that you can put lah. You will update accordingly. Mass is 700 grams. Okay, let's go back to your static. You need to put a few fixtures lah. So fixtures, fixed geometry. Fixed geometry is probably at the bottom lah, bottom of the chair. So 1, 2, 3, 4. So click OK. So you've got 4 chair affixed to the bottom, but this one is overly fixed lah. It's like glued to the ground lah. So this is the fixture. Then you can put load lah, external load, put force, put on top here. This is under normal direction. This is okay. So you can even change the unit lah. Currently SI is in Newton. You can change to metric G. It's under now change to kgf lah. So this one you can put 100 and then click somewhere. It will be accepted lah. If you put 100 and then you click enter, it will be accepted also. So you have done fixture and then you have done load. Now go to mesh and then create mesh. Obviously you can slide all the way to the right for a better accuracy lah. And then you click OK. So I've got a failure in terms of mesh lah. So this failure, you can click mesh failure diagnostics. Where is the failure? It will tell you lah. Most likely at areas where you have very difficult geometry lah. I believe I know in this case. So the easiest way to fix mesh error, you go to mesh, create mesh. Just refine the size lah, make it more finer, maybe halfway. So halfway is okay already. I believe the failure that I had just now is probably at this location lah. Here you have very small geometry size. If I go to model, I can be able to see lah. See this one, very tiny location. So this one, the mesh has to be finer at this area. So that's the problem lah. So your mesh has been created. You can right click on mesh and click show mesh to view the mesh. You can even look for the details. Right click on mesh, click details, and then you will be able to see the statistics of the mesh lah, whether you have good quality or not. Currently, percentage of elements with aspect ratio less than 3, 0.88, meaning 88.2% kah. Percentage of elements aspect ratio greater than 10, 15%. So that's quite a lot lah. So this is not very good lah, the mesh. So in order to improve this one, I can slide this one further to the fine side lah. If you don't have a very complicated geometry, you will not have this problem lah. So this is done. Let's check back again. What is my details? Less than 3, 4.55 percentage, 4.55%. Okay, because this one is very thin now. Never mind, so let's just accept it as it is. Normally thin structures you have to analyze using shell shell method lah. But this one for another day. So this is done. So let's click run this, and then it will be able to solve for stress and displacement. Excessive displacement were calculated in the model. So If you click yes, it will try to solve approximate results. This is most likely because of the too high force being applied. If you're having problem, you can cancel. Cancel. Terminate simulation, yes. Save result, no. So most likely you'll be able to get away if you minimize this force. This force is 100 kilo, maybe it cannot withstand. If you put maybe like 10 kilo, it will be able to solve. Run. Now I don't have the excessive deformation error anymore. But it's still very, very long because of the vast amount of mesh. If your mesh is very, very small, you will have a lot of elements. It will take a long time to solve. Why is this so? Maybe my thickness is too small. Cannot withstand. I'm going to cancel. Terminate simulation. Save result, no. So I'm gonna change the thickness lah. Go to my shell. Where is my shell? Edit, change back to 3 mm. Okay. Go back to my static. Do I have some failure here? Fixed. Is it failed? Maybe not. Oh yeah, it's failed already. I'm gonna delete this one. Do it again lah. Fix geometry. This location. So this 4 location lah. I can change my symbol size lah if I want to make it bigger, for example 300 if I want. And this is the symbol size. And then I'm gonna click OK. So fixture is there. I don't have a problem with my force. Let me change back to 100 kilogram. Click OK. Create mesh. I'm gonna go reset this one lah. Try. Maybe I can get a faster results by not having so many elements. If I go here and click details, how many elements do I have? Total nodes about 18,000. Total element about 9,000. So this is very, very small lah. So I should be able to solve easily. I'm gonna click run this. Okay, so this is almost done. So this is my results. If I go here, stress, right click, click show, it will give me a stress results. So the values here is a little bit confusing. I can go right click here, edit definition. Make sure our unit is here lah, megapascal. I can change here also, chart option, show maximum annotation, and I have to make sure scientific ni change to general lah. And then I'm going to click OK. So I will get the result lah. Maximum is about 19.7. So if I go to my model, see, it will update lah. Maximum stress 19.7, maximum displacement about 19.7 millimeter also. So these are the sensors which has already been updated lah. So you don't have to go all the way to evaluate all the time lah. So right click, show. I can even show my stresses. If I go edit definition, right, I can go to setting here, boundary option. Instead of model, I can click mesh. Continuous, I change to discrete, and then I'm going to click OK. So discrete scale is easier to read scale lah. Where is my maximum stress? Somewhere around this corner lah. This corner is the highest stress. So if you would like to determine area of interest, you can even click this one, design insight, and then you have to slide this one, most loaded. So the moment you click, it will show you where are the areas which is most loaded, which is most likely to fail lah. So apparently it starts at this corner. This corner is having pretty much high bending stress lah due to the corners there. You can slide, so I know which area I need to take care lah. So I'm going to click X. Go back here, show the stresses. Another method that I can do is I can double click on the scale. Currently it's 19.7, right? So if I double click, let's say I change this one to 10, make it lower, and then I will be able to see lah. Anything greater than 10, it will be in red color. Double click, change to 5. So anything greater than 5 megapascal, it will change to red color. So this is another method for me to determine lah. So stress is one thing. Another thing that you need to take care is something called displacement. So click show. This one also you need to change again lah. Displacement, right click, edit definition. Your unit is millimeter, okay. Show maximum annotation, scientific change to general. Setting here, continuous change to discrete. This model change to mesh, and then click OK. So we'll give you everything lah. And obviously you should always check this first lah. Go to plot tool and animate. So this is to verify that what you're doing is okay. There is proper deflection lah due to the stress given. So it's flexing that way. So the moment somebody sits on the stool, it will flex that way lah. It will bend like that. So the bending is causing the stresses lah at the corners. So you want to minimize this bending. How do we do that? Obviously the easiest way is for you to add some ribs. So I can click OK. And obviously I should print screen. This is my current state of the stool. And then I should update my PowerPoint slides. It will be under somewhere here. Create a new slide. This is my current displacement lah. And then I add a new slide. Let's look at our stress. Show. So this one I can double click here, change back to original. How do I do that? Click this one code. Click OK. 19.7, but this one you cannot see much lah. So might as well change to something reasonable. Maybe 10 or maybe 5. So this is looking at maximum. Anything above 5, maybe this is your criteria lah. Anything above 5 is red color. I'm getting maximum about 19.7 here. So print screen. Let's record this result lah. Put it over here. So make sure you are aware of the scale. Currently my scale is 5 maximum. This one 19.7 So the best way is when you want to compare before and after, make sure the scale is similar lah. Let's say this one 19.7, right? I can double click. Let's say maybe I change to 20. So my scale now is 20 lah, from 0 until 20. So later when you do improvement and you want to publish the result, make sure the scale is similar. So you are really comparing apple to apple lah. Okay, let's try. So one result for stress, another result for displacement lah. This one is stress von Mises. And another one is displacement. Okay, so let's do the improvement lah. So in order to do improvement, obviously the best way is for us to do ribs at the bottom here. So obviously you know how to do it already. So I'm just gonna redo the things that I've done before lah. I'm gonna slide this thing. I did my ribs. So these are my ribs. Cannot see I gotta change color. Change color to yellow. Cannot it's stick to this material color lah. Can I clean it like this? Cannot chair, stool, base appearance, X, this one, all such instances. Click this one. Can I update to any color that I want? Cannot lah. I just have to click certain features code baru boleh. This color, it will update a few features only. Okay, I get the idea lah. Once you apply the material it becomes updated to that material's color. That's the problem lah. So I have to highlight everything Appearance, don't have to do this I just wanna be able to show what I'm doing. Say those are the ribs lah. Original design is like this, no rib. And then I am doing rib. Once I do the rib, I fancy some sort of cutout for people to hold it easily. And then I have to do the rib for the cutout. Finally, I have to do draft for the cutout also lah. So this is the final feature that has been done lah. So once you have done this, go back to your static 2. I can just remesh lah, go to mesh. Because all my fixture are okay already. My force is okay already, similar. So just create a new mesh. Hopefully everything is okay. make sure you have the similar mesh density lah from previous to the next one, and then I can run this again lah. So once I've run it, my stress will be here. Oh, see, maximum is only about 2 point something only. If I paste the picture next to each other, print screen, right? And then I paste here, Control V. And put it next to each other. So maybe something like that. So you can see I am using the same scale, right? This one. Maximum is only 5 megapascal. Maximum is only 5 megapascal. So this is comparing apple to apple lah. So I don't have any more areas where you have higher than 5 megapascal stress. From 20 megapascal maximum up until about 2. So how much have I improved? Maybe about 20 divided by 2 lah. How much is it? 20 divided by 2.5 lah. That much lah. Maybe 10x, much better. So this is just comparing on the stress results lah. Okay, so next I'm going to compare what happened to my displacement. So right click here, click show. Obviously lah, maximum displacement is only 1.01. Print screen, I won't have anything. Can I print screen? So print screen the result. You'll be able to get it now. Put it next here, Control V. So this is like 20x much better lah. From 20 mm, around currently is about 1.01 mm only lah. So this is using the same scale. If you are using automatic scale double click this one, right? Click automatic. You can see like this lah. Depends on you lah how you want to show your results. This one is quite good also. You can see the behavior changing. Control V. Which one do you prefer? I think this one much better lah. 20. Yeah. This one is not meaningful lah. This same scale, not really that meaningful. So delete. This one is good. Bring to front. Let's do the same thing on stress. Show. Double click. Auto. Click OK. Yeah, you can see the stress is like this. I think this one is more meaningful lah. Change. Paste. There you go. So write something lah. Stool without ribs. Stress maximum is 19.7 megapascal. This one still stool with ribs. Maximum stress is 2.56. 2.56. Even better if you can show it at the bottom. There you go. You are showing all the ribs there. You are showing your new design there. Delete. This one is much better explanation lah. So similarly at this one, show displacement again. Like that. Okay lah, depends on you lah, how you want to put it. So this one and this one, Ctrl C, Ctrl V. This one is displacement max. Displacement maximum is 19.7 mm. Stool with ribs. Displacement max is 1.01 mm. So there's a big improvement lah. So you can put a summary statement. Improvement of about 20x when ribs are introduced. Something like that lah. Create your own word lah. So if you go back to your SolidWorks, go to model, the sensors will update accordingly. Yeah, you get a higher mass lah, 1 kilo. Who wants to buy a 1 kilo stool? That's not logical. Okay lah, for the purpose of the study. Stool should be around 300 grams only. 1 kilo siapa nak beli? Okay, so that is on the stress analysis lah. So once you've done that, you can go back to your features. You can save lah, everything save. The next thing that we want to do is we want to go to SolidWorks add-ins. It's not here. You just have to right click lah. There's something called a mold tool. Right click, turn on this one, mold tools. If you have already turned this on, it's okay lah. So now we're going to do the mold. First part is to do, of course lah, evaluate draft analysis. Currently it's 3 degrees. I'm changing this one to top plane. That's my direction. Let's say I change this one to 1 degree. And I click face classification, so I don't have a problem lah. Everything is green on the other side, everything is red on the bottom side. So you have a clear separation lah between your cavity and core. So if you're getting some errors, it's probably because you have to change the specs of your draft angle. If I change to 3 degrees, I'm going to get a lot of error. because these ribs I am doing it with about 1 degrees only. The draft change to 1 degree, everything is fine. You can even go as low as 0.5. If I change to like 5 degrees, everything will be in error. This is just your specs change back to 1 degree. So if you are getting like this, so your design is ready for mold So click X. Okay, let's jump over to mold tools. First thing is to create parting lines. This one is asking for the direction. Click top plane. Click draft analysis. And then you will see a purple color parting line. And then click OK So your parting line has been done. Afterwards, you need to do something called a shut off surface because you have a hole here. Shut off surface, and then you will select this loop and then click OK. It will automatically shut off that surface for creating the cavity. And then click parting surfaces. Make sure it's quite big. Currently 17, change to maybe to 60. And make sure you are not using normal to surface If you are using normal to surface, the parting surface becomes slanted a bit like that, so you don't want that to happen You don't want to be having a weird mold cavity core. Make sure it is perpendicular to pull, so the mating surface will become flat at your mold. If you want to make your mold bigger, change it to much bigger, maybe 100. 100. And then click OK. Afterwards, create tooling split. Select your top plane and then click Ctrl 8. Choose a center rectangle, put at the center. Make sure your mold size is not big like this. It has to be within the boundary of your parting surface Maybe this much. You can even dimension your mold size. Currently my mold size is about 600. 600 cannot fit our injection molding machine already So 600 by 450 is my mold size. So I'm going to click OK. I'm going to exit, and I get my mold size This is the size of my mold. So if I click Z axis, it become like that So currently the cavity thickness is about that much. The core thickness is about that much. Obviously you can change here 60, 300. So total thickness of my mold is about 360 mm. I'm gonna click OK. So this is the cavity and core which has already been created So last thing is you need to go to solid bodies, right click, save bodies, auto assign names. Make sure you untick this one, consume cut bodies, untick, and then click browse somewhere on your desktop. So this is called mold, M-O-L-D, mold stool, maybe something like that. Click save and then click OK Click yes, yes, yes. Rebuild and save document. And then you're done You have to go to window and look for this one, mold stool. So this is an assembly file which consists of parting line, which is your part. Change color. Change to green color maybe. tooling split, which is your cavity, change color to maybe whatever, and then your core, change color to purple. So this is the whole thing lah. So next thing, go to here, which is configuration manager, right click, new exploded view, and then you're going to click your cavity first, take it up, and then click your part, take it up. Oh, not enough. This one higher, click OK. Expand, animate, collapse. It's a little weird, right? Okay, stop. Right click, X is one, right click, delete. Yes, let's do it again. New exploded view, click the cavity, take it very high, click your part, take it all the way there, and then click OK. And then animate it again, animate collapse. This is the animation of the molding process lah. You switch to this one, it will playback mode reciprocate. It will go back and forth lah. So now you can inspect your tooling. What is happening to your cavity? What is happening to your core? The hole at the cavity, there's no hole at the cavity to make the hole. The hole is made by the core side only, like this. So your core side has a lot of opening for the ribs. So now you know which feature that you can do during your molding, which feature you cannot do during your molding lah. I'm changing to half speed. Okay, you can screenshot whatever you want lah. So click OK. Let's go back to your chair, stool punya part lah. So if you see here, there'll be lots of things here which has already been done, which is your tooling and such lah. So this one, now we're going for mold flow analysis. So in order to do mold flow analysis, you cannot have all this tooling lah. You have to go at the bottom, make sure the arm comes right off. Tu tangan tu. So over here you click all the way up until parting line. So you only have your part. So you cannot do mold flow analysis with all these toolings. You become erroneous lah. So this tooling is just for you to create this done lah. Just want to do this one only. Just want to grab this one out. So once you've done this, go back to your original file. You can rearrange. Go reverse back. What do we call this? Make sure the tangan is there and then directly go all the way until before parting line. So you can only do mold analysis here. So in order to do mold analysis, go to, I guess you should save first. Save. Go to SolidWorks add-ins, click one time only, plastics. If your laptop is not so fast, you can turn off things like this one. Simulation, you can turn it off. Do you want to save simulation data? Yeah, save lah. If you turn it off, it will unload lah from the memory. It will save some memory lah. So now this one has been turned on. You have something called SolidWorks plastics. So let's do mold flow analysis lah. So if you go to your tab, there will be another tab coming out, which is plastics manager. So over here we will be only using shell elements lah. Solid is much more accurate, but we do not have the time for this. You should do this during your working lah. If you're working or if you're doing final year projects, very important for accuracy, go for solid.